Okay, so coming in at number 9, everyone, we have a young couple that wants to have a college fund that will pay $30,000 at the end of each half year for 4 years. And so what we need to figure out first is how much money has to be in that account for them to be able to make that size of withdrawals for that long. And for that, we would need a present value of ordinary annuity. So if they can invest at 8.8% compounded semi-annually, how much do they need to invest at the end of each 6-month period for the next 18 years in order to begin their college withdrawals 6 months after the last investment? Now, I just did this problem a moment ago and I had to erase all my work because I made a mistake. The time for this portion, everyone, is not 18 years. The time for this portion is 4 years because we're trying to figure out how much money needs to be in the account so that they can withdraw $30,000 every 6 months for 4 years. We're going to be putting into it for 18 years, but we're going to be drawing out of it for 4. And so we want to find the total amount that needs to be in there. So our rate is going to be 0.08. Our M is going to be 2 because this is going to happen semi-annually. And so I is R over M, so 0.08 over 2. And that gives us 0.04 for our I. And N is MT, so 2 times 4 is 8. And so we want the total amount that will produce 30,000 every 6 months for 4 years. And my I is 0.04. And N is 8. So in Wolfram, everyone, we can see that I made a mistake and I put 18 in there and I ended up with 36 instead of putting 4 and getting 8. So there's my numbers in the formula as they should be. And we see that we need $201,982 and some change in that account. So 201,982.35. So for these people to be able to take 30,000 out every 6 months for 4 years, they need to have $201,982.35 in the account. So in 18 years, the account needs to have $201,982.35. So we need to work on producing or making payments into an account that will eventually sum to be that much. And so the other questions that we have here, everyone, are what was paid into the account, how much was paid out of the account, and how much did the fund grow? We'll answer those as we go. But the next piece is going to be for us to figure out, how much does our monthly payment need to be in order to reach this goal? So for this, we need a future value of ordinary annuity. And that looks like S equals R times 1 plus I to the power of N minus 1 over I. And so for this, we are looking for an eventual goal of having $201,982.35 in a fund. So 201,982.35 is what we need to have in the account. Our payment size, we don't know. That's what we're trying to figure out. Our rate is exactly as it was, 0.08. M is going to be 2 times a year. And T, this time we get to invest for 18 years to try and reach that goal. So R over M, we already had it. It's 0.04. And N is MT, so 2 times 18 in this case is going to be 36. So our formula will look like S, we know what the S is. So we're going to have $201,982.35. We want to know what size the payment needs to be to make that happen. So we've got 1 plus 0.04 to the power of 36 minus 1 over 0.04. So I'm going to run back up to the top here and grab my future value of ordinary annuity formula. Again, this is a situation where the value is going up because we are going to be making payments into it. So it's going to be future value of ordinary annuity. And we have S is 201,982.35. I is 0.04. And for our N, we have 36. So I got to divide 201,982 by 77,5983. And it looks like the monthly payment or the semi-annual payment that needs to go in is going to be $2,602.92. Oh, and 92 cents, not 9 cents. 2602.92. Yep. Okay, so monthly payments, or sorry, semi-annual payments of 2602.92 must be made to reach the goal. So somewhere in the neighborhood of $5,200 per year in order to reach their goal. Now let's consider some other things about this that are actually really interesting. For part B, how much was paid into the account? Well, we're going to pay $2,602.92 twice a year for 18 years. So pretty simple math there. 2602.92 times 2 times 18. We're going to pay in $93,705.12. So total payments, or total payments into the account are $93,705.12. Then we look at how much was paid out of the account. And so we are going to collect from this thing $30,000 twice a year for 4 years. So $30,000 twice a year for 4 years. And that's going to be equal to $240,000. So the total paid out of the account is $240,000. Now keep in mind, we only had to invest $93,000 in order to pull out $240,000. The other piece to keep in mind, this guy up here, in the 18 years that we were investing, our investment grew to $201,982. And because we pulled money out slowly to the tune of $30,000 every half of a year, the value of the investment went from 201 up to 240. We gained another $39,000 by not pulling it out all at once, but instead by pulling it out slowly and letting the money letting a large chunk of money still hang out in there and make money for us. So for Part D, the fund grew about, we went from 94,000 basically to 240,000, which is about $146,000. So again, these people made $146,000 for doing nothing, which is pretty incredible.